In this video, we are going to discuss about configuration of Ospf. So we have discussed a lot of theory in the previous chapters, and now we are going to discuss about how configuring of Ospf will come. So you see here router A, router B, router C, router D, router E and router F. These are all connected and we have to configure Ospf on these routers. You see, after getting into the area of all the routers, the area is divided into smaller areas to have a troubleshooting or the performance of Ospf in very high interfaces. You see here, router A and router B formed an area called area 1, and router C and router B formed an area called area 0, and C, D, E, F have formed area 2. So we have to configure Ospf here, and you see, as like EIGRP, Ospf configuration is divided into two parts. So what are the parts? Global configuration and interface level configuration. So global configuration and each interface level configuration here. So globally configuring Ospf includes enabling the process and adding networks to be advertised. That means we enable a process in the global configuration mode, and then what we will do is we will advertise the adding networks. That means what are the networks getting added, we advertise to all the routers to know that these routers are being advertised, or these routers know about the adjacent routers or the neighboring routers here. To enable the Ospf process, use the router process ID. So what is Ospf router process ID? The router process ID is unique ID given to that process so that it can get differentiated with the other process or other Ospf process if you want to configure other interfaces also on that router. So you see, the same thing is mentioned. So this command Ospf process ID, the process ID is locally significant number. That means it is locally significant to that interface and does not represent entire autonomous system number. So that does not represent entire autonomous system number. It only represents that particular significant process, and that process ID is given to that process. Since multiple Ospf processes are running, so each one will be having a separate processes and the process IDs here. So you see how the summary or how the syntax looks like: network, network number, wildcard mask, area and area ID. So we will be discussing each and every detail here. And if you see in the above command, network number and wildcard mask combine to identify an interface on which the Ospf will be configured. That means on which interface the Ospf is getting configured. So they combine, the network number and wildcard mask are combined to identify that interface so that the communication is very easy. While network number is a network address, example you can see 192.168.1.0 is called a network address for IP address assigned to that network, and a wildcard mask is the inverse of the subnet mask. So the wildcard mask is the inverse of the subnet mask here. So in a subnet mask, if is a 255 in octet means, so that here the corresponding octet in the network number should match exactly with 0. So if the other numbers are 0, the octet number is 255 here. So this is how we will consider about the syntax and we differentiate here. So we will be discussing about the areas and area codes in the next video.